All right, so in Chapter 3, Section 4, we're going to be talking about exponents and division. So we just got done in Section 3 talking about exponents and multiplication, and that was a 3-part video. This one's going to be just a 2-part video because there's only 2 rules or properties, whatever you'd like to call them, when it comes to division. And so division's the opposite, the inverse operation of multiplication. So we're going to kind of use that to work through our rules for exponents and division. All right, so our first rule, and what this video will be about, is our quotient rule. And what the quotient rule states is that if, or for any, I should say, any integer a, m, and n, where a does not equal 0, the following is true: that a to the m over a to the n is equal to a to the m minus n. So remember when we did product rule, we added our exponents. Well, now that we're doing the quotient rule, and division is the inverse operation of multiplication, well, subtraction is the inverse operation of addition. So we're going to do the opposite when we divide, and so we're going to subtract. And the reason this works is, for instance, if we have a to the 4th power over a squared, that would be the same as having a times a times a times a over a times a. And so here, these would each become a 1, and this one would be divide out to 1. And so we would be left with a times a, which is the same as a squared. And so that is the same as doing a to the 4 minus 2, which gives us a squared. And so those, but that's the reason why. If we were to write it out, they would divide out equally top and bottom until we have just so few left, or however many left. So let's actually see this in action. Example 1. And again, we can do this because, I guess I didn't mention this, we have to have that same base in order to do the subtraction. If we don't have the same base, we can't do the subtraction. It's kind of like with like terms, and you can only combine x's with x's and y's with y's and numbers with numbers. It's the same thing when we're working with exponents. We need those same bases. So when I look at example A, I have the 8s. I'm not going to actually divide out the 8. The 8 is going to stay, and so we'll get 8 to the 10 minus 7, which is equal to 8 to the 3rd power. And that is it. So same here, we're going to have y to the 13 minus 9, which will equal y to the 4th power. So I'm just subtracting. 13 minus 9 gives us 4. Now here, when I'm looking at C, D is my base for my exponents. The 2 and the 8 are their own. I am going to simplify them. 2 goes into both 2 and 8, leaving me with 4 on the bottom and 1 on the top. And then we're going to do D to the 20 minus 13 on top, because we're always going to do top minus bottom, at least at this point. And I say at this point because there'll come a different point, and I'll tell you why. So we'll be left with, I'm going to undo that 1, and I'm just going to leave it with D on top. 20 minus 13 is 7, so we have d to the 7th power over 4. Or you could write this as 1/4 d to the 7th power, or 1 d to the 7th power over 4. All of those are equal. And so that is how the quotient property works, or the quotient rule works. We just subtract our exponents. So if you can subtract, then you can do the quotient property. Until next time.